Okay, we're going to take a look at section 2.1. It's about transformation of quadratic functions. Now, remember, in chapter 1, we talked about transformations of linear functions, absolute value functions to start off with, and a lot of those concepts will apply right here in chapter 2. Quadratic functions, you should know, are parabolas. Remember, you learned in Algebra 1 the quadratic formula, and it has that word quadratic in it. So what is a quadratic function? The first and foremost, it is a parabola, and you will see that in the equation it has x squared, or it has something to the second power as the highest power in the equation. So if it doesn't have x squared, then that means it's not going to be a quadratic. If it has x squared, but also maybe let's say x to the third, then it's not a quadratic either. So x squared must be the highest power in that function itself. So hopefully we understand right here that a parabola is this U-shaped function. And so let's go drop down to the vertex of a parabola. If we think about a parabola itself, it's U-shaped, and the vertex happens to be right at the center. Okay, so right there. This will represent our vertex, and if my parabola is facing upward right here, then that tells me that this happens to be the lowest spot of our parabola, and therefore it is considered the minimum. So upward facing minimum. If my parabola happens to be facing downward right here, then the vertex happens to be the maximum of the parabola. Okay. Several things. Remember, a parabola happens to be symmetric in shape. So we could actually draw a line that goes through this, through the vertex, and we call that the axis of symmetry. And then points are equidistant from either side of the parabola from this dotted line that I have here. Next up, vertex form. Y is equal to a parentheses x minus h quantity squared plus k. All right, so remember, when it came to a linear equation, and we talked about horizontal and vertical shift, there was that value of h and k. Inside the parentheses, if it's x minus h, then it's going to go to the positive direction or to the right. If you see x plus h, then the function will shift to the left or to the negative side. Think about it this way. We had absolute value functions, and inside of the absolute value was x and then plus or minus h. And so inside the absolute value, we took the opposite to shift our function left and right. That k value will tell us how much it is vertically transforming, up or down. And then that a value right there will tell us how much our parabola is shifting up or down. And also one other thing, and we'll take a look at that coming up. So as we take a look right here, our horizontal translations. Once again, if we have f of x is equal to x squared, that is the parent function. And then they're saying, well, if we take x and then we subtract h to it and square it inside the parentheses, it will tell us if h is less than 0, it shifts to the left. If h is greater than 0, it shifts to the right. The same thing occurs right here. Let's take a look at a vertical translation. Now, when we add k, and if you look at this, this is to the, remember, when it's added to the function, all right, that right there happens to be, or it's adding to the whole entire thing, so we could say output, right? So actually, let's go ahead and say this right here. Or this is adding to the entire function, So you can see that vertical translations affect the output. Horizontal translations affect, right here, the input. So let's add those two right there. And we talked about input and output a lot in chapter 1. So if the output is positive, it will move up, right? That's why it shifts up when k is greater than 0. It will shift down when k is less than 0. So I will continue to use the terms input and output, and you guys should be able to recognize that throughout. When we had x-axis reflection, when it came to linear lines or linear functions, that impacted the output, right? The whole entire thing, we changed the sign, as you can see right here. So we'll go ahead and put output. So you'll see at times a negative sign outside of the parentheses is where you could tell, all right, we have x-axis reflection. Or if you, and then when you go ahead and simplify it, it becomes negative x squared. So if you see something like this right here, negative x squared, that should also tell you that we have x-axis reflection. Now, when it comes to y-axis reflection, this will impact the input. And remember, when it's the input, it will affect directly onto the x itself. Remember, if you look right here with the output, it was on the outside of the parenthesis. With the input, you can see right here, the parenthesis inside of it, and next to the x is where the negative sign is. So when I do, however, simplify this, and you take negative x squared, which happens to be negative x times negative x, that gets us positive x squared. And you can see that the function actually stayed the same. Because think about it, when it's a y-axis reflection, it's a mirror like this, right? It's going from left to right. So therefore, it's going to end up being the same thing, at least if there is no horizontal shift. We taught, next up, horizontal stretch and shrink. Remember, things got a little tricky when it came to horizontal stretch and shrink. First off, horizontal stretch and shrink is the input. And so that means that now my A value is will tell me whether we have horizontal stretch or shrink, okay? The A value. So if now you can see that that is notated right here, where we have A, and then since it's affecting the input, it's A times X, and it's inside the parentheses. Okay, that's important to know. So several things, remember, when we talk about horizontal stretch, okay, where we're taking it, stretching it out this way, it's a little bit different because horizontal stretch, remember, you take the reciprocal of the A term. Okay, so when it comes to horizontal stretch and shrink, A value, let's go ahead and put it this way, your A value will be the reciprocal of the factor. So if it's horizontal stretch, they may tell you that it's a horizontal stretch of 5. However, you take the reciprocal of that, and that will turn it into 1 over 5. And that's why they say horizontal stretch is less than 1 and greater than 0, your A value. When it comes to horizontal shrink, then you take the reciprocal. So they may start off with, they'll say it's a horizontal shrink of 10, or sorry, let's say 1/10, and then you take the reciprocal of that, and then it happens to be 10. And that's why right here, your A value is greater than 1. We move on to vertical stretch and shrink. Remember, this right here will affect the output, the entire function. And that's why they put the a times f of x. Now, when it comes to vertical stretch and shrink, you take the a value as is. If it's vertical stretch, your a value will be greater than 1, as they show you right here. When it's vertical shrink, it will be less than 1, greater than 0. And remember, the reason why it has to be greater than 0 is because if it becomes like -5, that's not really a vertical shrink. The negative represents the fact that we have a reflection across the x-axis. So that's why it's important to understand that it has to be greater than 0 right there. And if it ends up being 0, well, 0 times anything will turn into 0. So let's put all that together right here and take a look at how we could describe the functions of f of x is equal to x squared. So if I take a look at number 1, my a value right here is 1. It's not there, but it actually is. It's 1x squared. So that should tell me right now, all right, there's no vertical or horizontal stretch or shrink. Okay, so if I take my parent function, which is x squared, it's the same thing. And the only thing that's different right here is that this plus 4, which happens to be the output because the whole function got added by 4, right? That should tell me that it has moved up 4 units. Okay, this right here, up 4. Now, from here, what I could figure out here is this. Where exactly is the vertex? Okay, remember our function right here happens to be f of x is equal to a times x minus h plus k. And h and k happen to tell me where my vertex is. The way this is set up, there is no parenthesis. Okay, so we have x squared. And so think about this right here. If I put x minus 0, then that tells you that my h value happens to be 0. That's how we end up with x squared, right? If I were to, once again, I'm showing you right here, if I have x minus 0 quantity squared and I simplify this, that turns into x squared. So that tells me that my h value is 0. My k value is 4. And so by doing that, I can figure out right here, just by looking at this equation, that my vertex is at 0, 4. Now that's helpful because if you want to graph this, and which you're supposed to, and in the beginning you're uncertain of what's supposed to happen here with the graph, what I start off with is figuring out where's the vertex. If it's at 0, 4, then I'll put that in the middle. I'll choose numbers greater than 0, like 1 and 2, less than 0, -1, -2. I need to figure out what the vertex is first so I know where to begin my points, or what points to choose to plug in to my equation. And so let's go ahead right here. 0, 4 happens to be the first point, and I'll plot that down right there. And then next up, let's go ahead and introduce some points into the function. So we have 1 squared, right? Plugging that in, plus 4, that gets me 5. When I plug in -1, that should also be 5 as well. Now remember, here's the thing. These are supposed to be equidistant. Remember, I told you earlier that a parabola is symmetric. So if I go right here at 1, 5, which happens to be right there, since everything is a -1, 5, and look, these points are on opposite ends, and they're supposed to be. Let's plug in 2 into our function. 2 squared is 4, plus 4 we have 8. At -2, you should get 8 as well. You could do the work. -2 squared is 4. Add 4 to it, that gets us 8. So right here at 2, we are up here at 8. And then at -2, we are up here at 8. And then don't forget, the intervals that they show you here happen to be intervals of 2. And here is your parabola. The parent function would be the same thing, but down here. Okay, and you can see the description, it went up 4 units. Okay. And there you have it. Let's take a look at number 2 next. So right here at number 2, this looks a little bit more familiar to that of vertex form, right? Showing you right here. This one was not, but it actually is. It's just been simplified in number 1. So let's start off. We figure out the vertex. Remember, with the absolute value function, you took the opposite of what it was inside the absolute value. You're going to do the same thing right here when it comes to a parabola. Or what you could do is you take that x minus 1, set it equal to 0, and you'll get yourself positive 1, right? So right here, my vertex is going to be at 1, -3. Once again, I take a look at what's inside right here. It happens to be x minus 1, which tells me that I want to shift my function 1 unit to the right. You take the opposite of what's in there. Or simply take x minus 1, you set it equals 0, and x equals 1. So I use that information. I'll plug right here 1, -3 into my vertex, or into my table as my vertex. And this time, because my parabola has shifted, I'm not going to use -2, -1, 0, 1, and 2 because it moved over. So if I use those 5 points, you're not going to get a good picture of your parabola. You always want to start with what the proper vertex is, and then pick your other numbers. I will choose 2 and 3, 0, and -1. And then we'll have our numbers right here that make things symmetric. So let's go ahead. I'll plug in numbers. You plug in 0, makes things easy. 0 minus 1 is -1. You square that, that's 1. 1 minus 3, -2. So we have -2 right here. And then at 2, we also have -2. Doesn't matter if I plug in -1 or 3. Let's plug in 3 since it's positive numbers. 3 minus 1 is 2. 2 squared is 4. 4 minus 3 is 1. All right, so we have our points. Let's plot them now. So at 1, -3, there's my vertex. At 0, we're at -2, right there. At 2, we're at -2. At 3, 1. And -1, 1. So the shape of the parabola stays exactly the same because, once again, my a value is not greater than 1 and it is not less than 1. So due to that, the shape of these parabolas will look exactly the same. Let's move along. Give you a few more examples here. Well, now that hopefully you know how to pick your points for your parabola, what I'm going to talk about is just figuring out where is the vertex first off. On this one, your h value is +9. So what that tells me is that, remember, if you take that and plug or set it equal to 0, the x plus 9, you should end up with -9. And that will end up with your h value. So my vertex right here is going to be -9. My k value is out here. Well, there's nothing there. That means it's 0. Okay? So a few things. First off is that my function will actually move over. Okay? I'll give you a brief breakdown of it. It's going to be moving over -9, so 6, 8, or actually this time around we have intervals of 3. All right, so -9 will happen to be right here. And there's something else that you should be able to notice. We have this negative out in front. Remember, negative out in front is input, or sorry, it is output. So that means this has x-axis reflection. And it's going to go downwards. So it'll look something similar to this right here. The rest of the points that I'm putting down, they're not the exact points. You could figure that out by plugging in the numbers, okay? But it pretty much should look like numbers 1 and 2. There is no vertical stretch, shrink, or horizontal stretch or shrink. And there's your graph. Let's move on. Let's take a look at number 4. Once again, number 4, there is no demonstration of a horizontal or vertical stretch or shrink. Your A value right here is going to be 1. There is no H, but there is right here. This represents the K. So my vertex will be at 0, -7. Remember, only if it's inside the parentheses do you take the opposite. For K, you do not. So right here, remember, if my parent function, it looks something like this, and you do this enough times, you remember the points for your parent function. All we're going to do is take our parent function and shift it down 7 units, which happens to be right here. And there you go. We'll draw, and make sure you make this U-shaped, not a V-shape, because I see that a lot of times when students draw these things out. All right, now let's take a look at number 5. I've got 1/3 x squared minus 6. If you have a number that is attached to the x squared, then that tells you that we're dealing with either vertical stretch or vertical shrink. Now, remember, when we're dealing with a, it could be vertical or horizontal stretch or shrink. It could be both. But when is it vertical stretch or shrink, or horizontal stretch or shrink? If you have parentheses in the question to start off with, then that should be a good sign or a giveaway that if you had 1/3 in parentheses x squared, or 1/3 x parentheses squared, then there might be, that would be more a sign of horizontal stretch or shrink, which means you need to take the reciprocal of that value. However, right here, we just have 1/3. So 1/3 is my A value. And if A is less than 1, greater than 3, or sorry, less than 1, greater than 0, then we have ourselves a vertical shrink. It's not shifting left or right. So my H value right here, I'll put it down below, is equal to 0. K is equal to -6. So my vertex here is going to be at 0, -6. However, this time, because it's shrinking vertically, you will see that the graph will become wider, okay, with the parent as opposed to the parent function. So right here, we can go ahead and say vertical shrink of 1/3, and then we have a vertical transformation or translation of down 6 units. And you will see that what happens here is that it starts to compress and it will become wider as opposed when you take a look at the parent function. Looking at number 6. we have right here, this time in parentheses, you can see we have -4, which this tells me right here definitely is your input, right? It's right next to the x. However, this time it is in parentheses. So that is a big deal right there. Another thing to take note of is this negative sign that is also next to the a value, and it's inside the parentheses as well. So two things are happening here. That a term inside the parentheses, we said it was input, so that should tell you that we have a horizontal transformation. Okay, what's going on? We have a horizontal shrink. So let's go ahead. First off, we have horizontal. We have a shrink, a factor of 1/4. It's not -1/4, it's just 1/4. So what does that negative sign mean? Well, remember, it's another input. If it's attached to our a value right there, that should tell you we have ourselves a reflection. Y-axis reflection. All right, so those two things are occurring there. And then you can put that into Desmos to kind of help you take a look exactly where the graphs are. And you will notice once again that that is, remember, -4 horizontal shrink. It's actually going to shrink it this way, so it's going to compress, and it'll look like it's a vertical stretch. All right, so lastly, let's take a look at number 7, and let's take a look at all of the things going on here. I'll give you time to take a look at that equation. Identify the vertex. I think we could do that real quickly. Remember, that's h, comma, k. H is right here, k is right there. We take the opposite of x minus 5, or you set that equal to 0, and you should realize that h is going to be 5, k is 7. So automatically described one of the transformations. It has gone 5 units to the right and 7 units up. Okay, so let's go ahead, describe the transformation. One of them, we have transformation 5 units right, and then I'll put 7 units up. There's two other things that are occurring. I look right here. This 10. Remember, that 10 represents your a value. It's on the outside of the parentheses. If a is outside, it's your output. And then that means it's going to affect the whole thing. So right here, if a is greater than 0, then, or sorry, a is greater than 1, then we have ourselves a vertical stretch. By a factor of 10. So that means this thing is going to stretch out quite a bit. Okay, factor of 10. Next up right here, there's one last thing. There's this negative sign out in front. Also, output. If the negative is on the outside and it's going to affect the whole entire function, then that right there is going to be reflection. And hopefully you know which axis. it's a reflection of the x-axis. So bottom line, here's what the function will look like at 5, 7. It'll look something like this. There's my vertex. It is stretched out, so it should be pretty skinny, like so. Going down, and it's going downwards because it's a reflection of the x-axis. It is going downwards. And there you go. There is your graph. Okay? Hopefully you figured this out, or will figure it out when you guys do your homework. Let me know if you have any questions. Bye-bye.